for this question, data were collected that included the information of weight in pounds versus the number of people who lived in the house. So let's see. I'm going to open up this data by clicking here and answer the questions for this problem. Okay, so here we have the people per household and then the trash, the weight of it in pounds. So the blue are the data points, and then this red thing is the best fit line that goes through the data. So part A is saying, is the trend positive or negative, and what does that mean? Well, the line is, the best fit line, and we have a couple of low data points here, but the best fit line is increasing, which means the trend is that as the number of people per household increases, so does the weight of the trash that is generated. So the trend is definitely positive. And as the number of people per household increases, well, that tends to increase the weight as well. I mean, that makes sense. For part B, it says, now calculate the correlation between the weight of the trash and the number of people. And it says to use an r squared from the figure. And then take the square root of it. Okay, so r squared versus r. So the way you'd go from this number to this number is by taking the square root of this value. And you can use any calculator that you'd like to do that. So I'm just going to pull up a basic calculator here. For starters, this is listed as a percent, and I'm going to convert it to a decimal by moving the decimal point 2 places to the left. So, or you could think of it this way, 46.9% divided by 100 changes it to its decimal equivalent, 0.469. Okay, that's r squared. If you want to solve for r, you would take the square root of this number. So I'm going to click this button, the 2 representing the square root. And so we get this. This is the r correlation coefficient. They're saying to round it to 2 decimal places. That's 0.68. Check my answer. Okay, great. Next, okay, report the slope. And just for that part of the question, the slope is how much this line is increasing by. And based off of this line, it's of the form sum slope times the variable plus the intercept. It's kind of written backwards, but here the slope is going to be the number that is next to the x variable, which is people, and that is going to be 9.21. So I'll put that here. So that's the slope. And it looks like the next part of this, they're asking for some type of interpretation of this. So for each additional person in the house, there are on average, well, it's asking for how much or how many additional pounds of trash. This is slope. It's not written as a fraction, but it's this number divided by 1. And if you remember, slope is rise over run. So if you go over 1, you go up 9.21. Well, that 9.21 is how much the pounds of trash is increasing by. So yeah, the slope is sitting right here. You could write it as a fraction whose denominator is 1, but this number is telling you how much the line is increasing by. So that should be my answer there, 9.21. Okay. And okay, there's one final part to this question. Okay, either interpret the intercept or explain why it is not appropriate to interpret. So for this thing here, the intercept, well, we already used 9.21. That's the slope. This thing here is the intercept of the line, which is 8.085. This intercept would be if there were no people that were living in the household. And this would be the predicted weight of the trash that is generated. Kind of seems like that's meaningless or inappropriate of an interpretation, just because that really doesn't make sense to think about, well, if there's no one living in the house, how much trash is generated, and it would be this number. So I think for this example, it's just I'd say inappropriate to interpret, because it does not make sense to think about a household with 0 people, persons generating trash. All right, so that is it for this question.